Okay, this is going to be a video on molecular formulas and then percent compositions we'll get to at the end. Just one thing real quick, if you have not watched the empirical formula videos, you need to go back and cover that, because to solve for these, we need to have that down pat. So you may want to go back and review that video. So these are the steps that we take to get there. But first, what is a molecular formula? Well, it can be the reduced formula, so like CH2, but not necessarily. It could be C5H10. So if you remember from our empirical formula video, we talked that we can have these different compounds, okay? And the empirical formula is the most reduced, but when we're looking at the entire formula, some of our hydrocarbons, they must be this larger compound. And so we're using this molecular formula procedure to figure out which molecule we're talking about. So the first thing we need to do to solve for the molecular formulas is to solve for the empirical formula. So again, that's why we need to go back and watch that video. The second step that we do, we calculate the molar mass of that empirical formula. Okay? After we have the molar mass of that entire compound, then we're going to divide that molar mass given by the empirical formula mass that we just solved for in step 2. Okay, so this number will be given to us. Now, if we need to, and we divide it into it, we see that there is a value that we can find. We multiply as needed. You may want to pause the video now and write these down, as I'll try to refer back to these as we go. So it always is best when we get a problem and we start looking at how to do it. So here's our first problem that we're going to take a look at. So we have a compound of ethylene glycol, and it contains 38.7% carbon, 9.75% hydrogen, and 51.55% oxygen. The molar mass that's given to us of the bigger compound is 62.07 grams per mole. So in this, we're trying to calculate the molecular mass. So just like we did in these other ones, we assume that there's 100 grams. So I'm going to take these percentages and make them into grams, and then we're going to solve for them as we go. So I'm going to sit down now and get after it. So I take 38.7 percent. I make that into grams for carbon, and we're going to convert that to moles of carbon. Okay. And then I find off the periodic table that 1 mole of carbon has a molar mass of 12. So I'm speeding this along. When I divide this out, 38.7 divided by 12, I get a mole count of 3.225 moles of carbon. Okay? Then I take the 9.75 percent of hydrogen, and I make that into grams of hydrogen, and I convert that to moles of hydrogen. Okay, the mole conversion for hydrogen is pretty easy, because 1 mole of hydrogen has a molar mass of 1. So the 9.75 is going to be our moles answer of hydrogen. Okay, so then I need to now take 51.55, and this is grams of oxygen. Now again, I just take that percentage and I make it into grams. Okay, and so 1 mole of oxygen, what's its molar mass off the periodic table, is 16 grams of oxygen. So 51.55 divided by 16 is 9.75 moles of oxygen. Okay, so if you remember our empirical, how do we calculate the empirical formula? I take each of these and I divide them by, this number is not right. It is 3.221875. Okay, when you divide that out correctly, Mr. Radford, that's what you get. So anyway, to find the empirical, you divide each of these by the smallest value, which is going to be this one. So obviously this divided by 3.221875 is going to be 1. Okay. This divided by 3.221875 is going to be 3. Okay, and this divided by 3.2205 divided by 3.2218 is going to be 1.009 something, so that's going to be 1 as well. I'm just putting in exclamation points just to drive this home. So what does this mean? Well, we just figured out the empirical formula for this is going to be 1 carbon, so it's going to be C, 3 hydrogens, H3, and 1 oxygen. Okay, so it's going to be CH3O. Okay, so that is step 1. Step 1 is done. Okay, all right, so now what do I do with this? Okay, so now I've got to take this, and now I'm going to figure out, so this is the empirical formula, right? Okay, so now I'm going to try to figure out the molar mass. Okay, the molar mass of this compound. Okay, so if you look it up off the periodic table again, if I have carbon, its molar mass is 12. I'm going to add that to the hydrogens. I have 1. They're 1 apiece, but I have 3, so it's going to be 3. Oxygen is 16. So when I add all of those up, the molar mass of the empirical formula is going to be 31 grams per mole. Okay, so I've now just done step number 2. Okay, all right. So now what do I do with this value? Well, they gave me the given amount that they give me in the equation is 62.07. So I take 62.07 grams per mole, and I'm going to divide it by the molar mass I just figured out, 31 grams per mole. Okay, when we do that, that tells us that we have 2 sets of this empirical formula. So what do I do with this value? I multiply this by 2. So think of it this way, 2 sets of CH3O. So this is going to be 2 times the carbon, which is going to give me an answer of 2 carbons. I'm going to multiply the 2 times the 3 hydrogens, which is going to give me a 6 hydrogens. And then lastly, the 2 times the oxygens, so it's going to be 2. So this is the molecular formula of the ethylene glycol that had those percent breakdowns of each of those. This is its molecular formula. This is not reduced. I do not reduce this anymore. Okay? So that should get you going on the molecular formulas. Now, what do we do if we're solving for percent composition? Okay? Let's just talk really quickly about what percentages are. What do they mean? Okay? So a lot of students get hung up on that. If you take a look at this, okay? So for example, so it says 80 out of 100 people like chocolate ice cream. 80 out of the 100 people polled. So think of this as, this is the part, 80%, and 80 people out of 100 is 80%. 80 is a part of all the whole that is calculated, okay, that is there. So that's why that's 80%, okay? So I take the part and I divide it by the whole, okay? I do the same thing when we're trying to figure out the percent composition of something. It's kind of working backwards from what we did. Now, we've kind of beat this to death a little bit so far in chem, but naming the compounds is super important. So tetracarbon decahydride, we started with this, learning this because you need to be able to write the formula correctly. So tetracarbon means that I have 4 carbons, correct? Okay, so it's going to be C4, okay, decahydride, H10. Okay, so we have tetracarbon decahydride, C4H10, okay? So now what I'm going to do is I am going to find out the parts of this entire compound. So to do that, I'm going to do the molar mass of each element, okay? And this will be the parts, okay, of what we're talking about, all right? So to do that, carbon, all right, we have carbon atom, okay, I have 4 of them, and their molar masses are 12, okay? So 4 times 12 is 48 grams per mole. That is the part of this whole compound, okay? I'll use a different color for this. Hydrogen, okay? Hydrogen's molar mass is 1, but I have 10 of those. 1 times 10 is 10 grams per mole, okay? So that's the part of this whole compound. So now I have to figure out what the whole compound is. So I'm going to take these and I'm going to add to get the whole. Okay, and so 48 plus 10 is 58 grams per mole, okay? So now to figure out what percent these are, I'm going to do what we did up here. We're going to take the part divided by the whole, okay? So on this one, I'm going to take, to figure out carbon's percentage in tetracarbon decahydride, its molar mass that we just figured out was 48 grams per mole, and I'm going to divide it by the whole, 58 grams per mole, okay? Again, this is the part divided by the whole. When I do that, I'm going to get a decimal answer, okay? So it's going to be 0.8275. How do I make that into a percentage? You multiply it by 100, or you move the decimal 2 to the right. That is the same thing. And I'm going to round that to 82.8%. Okay, so the decimal will go there. That'd round up to 0.8. Okay, now what about hydrogen? Okay, hydrogen, its part was 10 grams per mole. Okay, and now I'm going to divide that by, again, this is the part. I'm going to divide it by the whole, 58 grams per mole, okay? 10 divided by 58, we're going to get a decimal, 0.1724. To make that into a percentage, I multiply it by 100 again, and I'm going to get 17.2%. Now, the last thing you need to double check to check your work, okay, is going to be to make sure that these things add up to 100, okay? Or really darn close to it. If they don't, I know I made a mistake somewhere, but this would be rewritten as carbon makes up 82.8%, and carbon tetracarbon decahydride would be 82.8% carbon, and it would be 17.2% hydrogen. That's a 7 and that's a 1. 17.2%. And that would be my answers. Okay? So I hope that makes sense going through those percentages and explaining how they work. There you go. We'll see you in class.